Welcome to our exploration of transmission media in computer networks. Transmission media are the physical pathways that connect computers, devices, and other network components, allowing data to travel from one point to another. These media play a crucial role in determining the speed, reliability, and security of data transmission. In this video, we'll break down the main types of transmission media, discuss their characteristics, and help you understand how data moves across networks. Whether you're a student, professional, or just curious about how the internet works, this guide will give you a solid foundation. Let's start by understanding what transmission media actually means in the context of computer networking. Transmission media refers to the various channels through which data signals are transmitted from one device to another within a network. These channels can be physical, like cables, or wireless, using electromagnetic waves. The choice of transmission media affects network performance, cost, and scalability. Understanding the differences between each type is essential for designing efficient and reliable networks. In the next scenes, we'll categorize transmission media into two main groups, guided and unguided, and explore each in detail. Transmission media can be broadly classified into guided and unguided media. Guided media, also known as wired or bounded media, use physical cables to transmit data signals. Examples include twisted pair cables, coaxial cables, and fiber optic cables. Unguided media, on the other hand, are wireless and transmit data through the air using radio waves, microwaves, or infrared signals. Each type has its own advantages and limitations, which we'll discuss in the following scenes. Let's start with twisted pair cables, one of the most common types of guided transmission media. These cables consist of pairs of insulated copper wires twisted together, which helps reduce electromagnetic interference. Twisted pair cables are widely used in telephone networks and local area networks (LANs). They come in two main varieties: unshielded twisted pair (UTP) and shielded twisted pair (SDP). UTP is more common due to its lower cost and ease of installation, while SDP provides better protection against interference. Coaxial cables are another form of guided media, featuring a central copper conductor surrounded by insulation, a metallic shield, and an outer cover. This design provides excellent resistance to signal interference and allows for higher bandwidth compared to twisted pair cables. Coaxial cables are commonly used for cable television, internet connections, and some types of local area networks. Their durability and shielding make them suitable for longer distance transmissions within buildings. Fiber optic cables represent the cutting edge of guided transmission media. Instead of electrical signals, they use pulses of light to transmit data, allowing for extremely high speeds and long-distance communication. These cables are made of thin strands of glass or plastic, protected by layers of insulation and a tough outer jacket. Fiber optics are immune to electromagnetic interference and are widely used in backbone networks, internet infrastructure, and high-speed data connections. Guided media offer several advantages, including higher security, less susceptibility to interference, and more predictable performance. Because data travels through physical cables, it's less likely to be intercepted or disrupted by external factors. Guided media are ideal for environments where reliability and speed are critical, such as corporate networks, data centers, and telecommunication infrastructure. Despite their advantages, guided media also have limitations. Installation can be costly and labor-intensive, especially over long distances or in challenging environments. Physical cables are susceptible to damage from environmental factors, and maintenance can be disruptive. Additionally, expanding a network using guided media may require significant infrastructure changes. Unguided transmission media, also known as wireless media, transmit data through the air using electromagnetic waves. This category includes radio waves, microwaves, and infrared signals. Wireless media are essential for mobile devices, Wi-Fi networks, and long-distance communication where cables are impractical. Let's look at the main types of unguided media and their applications. Radio waves are widely used for wireless communication, including Wi-Fi, Bluetooth, and cellular networks. They can travel long distances and penetrate walls, making them ideal for both indoor and outdoor use. Radio waves operate at different frequencies, each suited for specific applications. Their flexibility and range have made them a backbone of modern wireless networking. Microwave transmission is another form of unguided media, commonly used for point-to-point communication links. Microwaves travel in straight lines and require line of sight between the transmitter and receiver. They're used in satellite communication, cellular networks, and long-distance data links. While microwaves offer high bandwidth, they can be affected by obstacles and weather conditions. Infrared transmission uses light waves just below the visible spectrum to transmit data over short distances. It's commonly found in remote controls, wireless keyboards, and some short-range communication devices. Infrared signals require a clear line of sight and are easily blocked by obstacles, making them suitable for controlled environments. Unguided media offer flexibility and convenience, especially for mobile and remote applications. They enable easy network expansion without the need for physical cables, reducing installation costs and time. Wireless networks support mobility, making them ideal for smartphones, laptops, and IoT devices. However, they also come with their own set of challenges. Wireless transmission is susceptible to interference from other electronic devices, weather, and physical obstacles. Security is also a concern, as data transmitted through the air can be intercepted more easily than through cables. Additionally, wireless networks may experience lower speeds and less reliability compared to guided media, especially in crowded or challenging environments. When choosing transmission media, it's important to consider factors like speed, cost, distance, and security. Guided media generally offer higher speeds and security, while unguided media provide flexibility and ease of installation. The best choice depends on the specific needs of the network, such as the environment, budget, and required performance. Different transmission media are used in various applications. For example, fiber optic cables are essential for high-speed internet backbones, while twisted pair cables are common in office LANs. Wireless media are crucial for mobile networks, public Wi-Fi, and remote areas where cables are impractical. Understanding these applications helps in designing efficient and effective networks. Security is a major factor when selecting transmission media. Guided media, like fiber optics, are difficult to tap into without detection, making them suitable for sensitive data. Wireless media require robust encryption and authentication to protect against unauthorized access. Network designers must balance convenience with security to ensure safe data transmission. The future of transmission media is shaped by advances in technology. Fiber optics continue to evolve, offering even higher speeds and greater reliability. Wireless technologies like 5G and beyond are expanding the possibilities for mobile and IoT networks. As demand for bandwidth grows, new materials and methods will emerge, further enhancing network performance. Selecting the right transmission media depends on the network's requirements. Consider factors like distance, speed, cost, and security. For example, a small office might use twisted pair cables while a data center relies on fiber optics. Wireless media are best for environments where mobility and flexibility are priorities. Assess your needs carefully before making a decision. To recap, transmission media are the backbone of computer networks, enabling data to move between devices. Guided media include twisted pair, coaxial, and fiber optic cables, each with unique strengths and weaknesses. Unguided media such as radio waves, microwaves, and infrared offer flexibility and mobility. Understanding these options is essential for building efficient and secure networks. In conclusion, transmission media are a fundamental part of computer networking. By understanding the types, advantages, and limitations of each medium, you can make informed decisions when designing or upgrading a network. As technology evolves, staying updated on new developments in transmission media will help you build faster, more reliable, and secure networks for the future.